Hi, everyone. Jonathan or John H. Bit or J. Harvey B. Uh, I was asked to tell you about Taproot Assets so you can win the hackathon or learn something, whatever you feel like doing. I used to work at Lightning Labs, so I spent a lot of time on this protocol, and I think it's pretty decent and totally appropriate for building something in a hackathon. Um, How many people in the room have like heard of it or looked at it at all? I know some of you. Okay, way more than I expected. Yeah, I'm gonna try not to explain it that much and just explain, how people are using it or what you could be building. Um, Anyways, so instead of using diagrams, I'd rather just use buzzwords and explain them as needed. Uh, so I'm not gonna read this. Uh, there's this term, client-side validation, that seems pretty well defined, which usually just means there's no global state, or if there is, you still have to like hold some state on your side as a client. And normally with Bitcoin wallets, we have like our 12-word, 24-word seed. With newer wallets, you may have like a wallet descriptor, which tells you exactly how to regenerate scripts. And you need both of those to like restore. With something that's like client-side validation, you also need, some maybe let's say proofs or like history data to actually be able to restore your wallet state. Some people have mentioned this earlier today. And that may, grow with every transfer or just grow over time. Or if you're doing fancy ZK things, it may not, which would be cool. That's like one drawback, sort of, or at least one feature. Another project that sort of has this feature is like Utrixo, which some people in the room work on or know about. And there was some shade thrown comparing runes and Taproot assets. I'll admit I haven't really looked at runes enough to like competently criticize it, but I'll just say there's some features of not using op return that are really nice. One thing is that you can compose this with a bunch of other protocols. So you can put assets in a Lightning channel, you can put them in an ARC, you can easily do, I guess, certain forms of swaps that you wouldn't be able to do if your protocol is using op return. But people are still figuring those things out, and maybe I'm wrong. In terms of being a meta protocol, you could say it's like an L2 or an L3. You can use assets on chain. That may make the most sense if you're doing something non-fungible. So if you're dealing with images or just assets that can't be split up into little pieces, you probably want to move things around on chain. You're going to be using Taproot transactions. All your tooling will be sort of the same as what you'd use if you're just moving Bitcoin around. So making some PSBTs, making some Bitcoin scripts, handling that. You could also, if you're dealing with something like a stablecoin or something that's fungible, put it in a Lightning channel, which is pretty useful in terms of privacy or just liquidity or being able to like actually send value somewhere for pretty cheaply. So some projects are working on that, which I will throw up later. And there was a slide here about runes. This is my slide. In terms of privacy and scalability, the whole protocol really just hides like some data in a TabScript tree. So it's like some script that you're never going to execute. So instead of like, a multi-sig script in your Taproot output, there's this random little leaf hanging out there. What this means is, I think there's a guy, B10C, that like does all these charts of like different output types on Bitcoin and like how Taproot's going up and old script types are going down. And basically there's absolutely no on-chain footprint. It just looks like a normal Taproot transaction. And if you don't have some sort of external data, there's no way for you to know, which assets are moving where or who was involved in that. That means you can also throw it in things like a coin join. As I said already, a Lightning channel. And you can do like some really cool batching. So you could have one Bitcoin transaction that's actually moving like, I don't know, 1,000 different assets or something. Because all that data is off chain and not really mapping to the UTXOs. So there's a nice line. Real G's move in silence like lasagna. Uh, I'd like to, not all the defaults for like Taproot Assets, client and server, maybe the most privacy respecting. So by default, there's these universe servers that like index proofs basically, or like track the transfer history of some assets, and the client will upload history to that by default. There's one run by Lightning Labs. Of course, if you don't want to do that, it's like a one-line config change to turn that off. And then you're responsible for like moving your proofs around and making sure the sender or like receiver of some transfer can actually get them, but you can do things in a pretty private way. In terms of, it's been around for, I want to say like 3 or 4 years. So people have started building on it, and there's this one guy, Megalithic, I don't know who this is, but they've built some pretty cool stuff. So specifically an explorer for like, image, non-fungible things. Also just an indexer, so you can search around the chain and see what people have done. And these universe servers, these indexers that I've mentioned, you can sync between them, so it's sort of like a federated kind of model, I guess, similar to, I don't know, Nostr relays or like Mastodon relays. So they can sync info from like the Lightning Labs indexer or some other private company's indexer. There's stablecoin-wise, it's like, images and stablecoins, I guess, is what we're making now. So there's, which is totally fine. But there's this company, Jolts, that's, I think they are working on like an SDK, web wallet, bunch of things. But they had this partnership with a Brazilian company to issue like reais stablecoins, so like for the Brazilian national currency. There's a wallet. I did not get any farther than this screen for these slides, but it works. There's this other company, Speed, that's doing like a private USDT bridge. So they've got like Tether in a channel, I guess they'll bridge it from ETH or somewhere else and then do cool invoices so like people can pay you in Bitcoin, you receive in USDT, or do the opposite. So that's pretty neat. They say they don't support users in the US, but I'm sure you can figure out how to deal with that. There's some other projects that seem really cool, but it's just like one person on GitHub with some code from like 2 years ago. So there'll be links for all this at the end, but there's like some DLC-based swaps. So if you want to swap in like a trustless way or on some marketplace, all the like DLC code and signing and logic can be used with Taproot Assets. So it's just normal like SecP signatures. There's cashew mints that want to support USD, so you could have, like most of these cashew mints have, one or a few lightning channels between them and some other parties. So you could put other currencies in there, which would be pretty neat in terms of privacy or just like being useful. And of course, you probably want to bridge things that are minted elsewhere into this ecosystem. So, that's sort of an open problem that you could feel free to work on. So if we think about what you'd actually want to do for a hackathon type project, again, like porting or bridging something that already exists, maybe there's things that you want to do that just aren't easily possible with like whatever this asset is in its current format. Maybe you want to do something really wild that in a short amount of time. The Taproot Assets like VM is just Bitcoin script VM, but it's using what's in like BTCD, and there's some open PRs of like, oh, put in opcat, or like, you could add another opcode and do some weird BitVM thing on this layer and not on the main chain, which would be cool. You could send around the proof data in different ways. You could send it over Nostr if you want. You could send it, I guess, maybe not Twitter, but like some other platform. You could send it on USB sticks if you think that's useful, or pigeons. So let's like think through like how would you port ordinals. As a disclaimer, I don't really understand them well enough to like, make a bunch of claims on details. But what I do understand is there's like some numbering system for sats, and you got to build transactions in a specific way, or else you burn it. And there's these indexers, and that's basically it. So if you wanted to port these to some other asset system, right, you'd probably need some sort of like tools for coin control. So you need to put this index like in a specific, put this input in a specific spot, put this output that's going to like hold the converted asset in a specific spot. You're gonna need some way to embed images in a way that like, is vaguely standard. Other people want to be able to decode them. You'll need something to replace like the indexer. And the last bit, I didn't think of anything that really makes sense, but you probably want some way to prove that the input like actually own that ordinal and like, put it in the new asset instead of just like looking at an indexer and saying like, oh yeah, that input actually own this asset. So if you decide to work on this, you should probably figure that out. There's a bunch of options, but these Taproot assets normally have like a metadata field. I think it's 1 megabyte right now, so you should be able to put like a decent amount of things in there. Probably not a massive ZK proof, but something else. And in general, the documentation for the repo is pretty decent, and there's a lot of code comments. There's also a lot of integration tests that go through a lot of like useful situations. So there's like one showing you how to do multisig with your on-chain inputs and these Taproot assets. There's one showing you like the details of how to use PSBTs. There's another one doing some strange swaps and like channel activity. So there's a ton of existing code that you could look at and like translate directly to your project. Let's say you're doing this, you're probably going to also want some extra validation logic for like these indexers. Maybe you'd add something to like the client as well. I mean, that's up to you. So we can actually go and look at some code. I should make this bigger. Too big. Okay. Yeah, Rise to VS Code is super useful. So I said look at the iTest. We're here in the iTest. There's a bunch of, on the sidebar, you can see like PSB related test cases. And to be able to put these assets in a channel, you have to be able to do like HTLCs and other fancy scripts. And this is just all the code for that. It's in the whole repo's in Go. If you want to do something in another language, there's tooling for that. But you're basically going to be, what is it? Like building these Bitcoin scripts by hand. If you want here, there's better tools you could use. There's this concept of addresses, so you could generate like static requests for different amount of assets and pass those around just like a normal Bitcoin address. There's other things in here about, the specific RPCs that you'll be using to like complete a PSBT that transfers different assets around. So these are also usable like from outside of the test environment. Other details that aren't important for a hackathon project. There's this idea of anchoring, which is like putting these assets in an actual like L1 transaction, which is sort of at the end of something you're going to be doing, and then moving these proofs around. So yeah, there's PSBT stuff in here. They added this after I left, but you can like use a ledger to sign for stuff, which is pretty cool. So a lot of external signing and like security related changes that are possible now that weren't possible like a few months or a year ago. So that may be cool to play around if you randomly have a ledger on you. There's other cool things you can do when you're minting assets. So there's, let's say you're some fancy company and you keep all your Bitcoin in a multisig. You can also mint assets and maintain that like multisig constraint on the Bitcoin output that's holding those new assets, which is cool. So you never have to like change what you're doing with on-chain scripts in order to also like embed assets in some Bitcoin output. So that's nice. This is mostly just, again, building some TapScript tree with some particular scripts in it. But if you need examples of like how to do that in Go, this is a great place to look. And some other things about like, if you're going to set up an indexer, which flags should you use? I mean, the like help pages are pretty good. Let's see. There's a bunch of flags here. If they start with universe, they're probably related to being an indexer. Anyways, so definitely look to the tests. And also there's like the official doc pages, so we'll hop over to that. So they like auto-generate docs from the actual, let me zoom in again. Okay, ignore the tabs on the side. From the actual like gRPC stuff, so if you're going to mint an asset and you're like, oh, what do all these fields mean? How do I do this? Here's example code. And meaning of all the requests. So it should be relatively straightforward to actually get these things working. There's also like a video series and like a bunch of repos from like developer relations, people that like have again like example Python code and such. You'll have to watch out for like macaroons, I guess, are this like permission system they use that can be hard to work with. In terms of other things you can do, when you have this like tap daemon running, you have these proofs that you need to pass around, and it's like just a file on disk. So there's like a SQLite database, but there's also just like files that will be generated as you do transfers. So if you want to, again, like throw it around on Nostr or something, you can just do that pretty easily. You won't have to change anything. Okay, I was going to try and decode a proof, but of course, because it's a presentation, something doesn't work. In this case, I cannot sync to testnet 3 fast enough. But there's this other project I worked on at like plebfi in 2023, which was pretty silly, but it was just like, oh, there's this image series, like CryptoPunks or something. I think it's like 10,000 images, and I was like, oh, can I port this to Taproot Assets in the worst way possible? So it's a bunch of bash. Whatever. But, it's like less than 200 lines of code to just like go through the full life cycle of minting something. You can, export these proofs and actually decode the images that I put in there. So if you want like a more concrete example of how to do multiple things with a daemon, that may be helpful to you. The link will be in the slides at the end, or just on my GitHub. Those examples were sort of all for non-fungible assets. Let's say you're doing something fungible. You want to do some stablecoin or something that looks like a stablecoin, or something else fungible. It gets more complicated. They have this idea RFQ, or like request for quote, which just means like I'm in a Lightning channel. I need like this channel has some other asset in it. We need to agree on a price, or like for every channel update that holds this asset, we need to agree on the price beforehand. So I want to send out like $10. We need to know what the price is. So there's this request for quote process. You're going to run this other oracle, this other process that basically handles communicating the price to like both sides of this channel. You're also going to end up running litd. It's like their bundled daemon sort of, so it'll run the Taproot Assets daemon, also LND, and like some other things, I think. That can be annoying to work with. Instead of doing something directly, they have this tool Polar, which is pretty useful for like making test networks. So you could like have multiple LND nodes, multiple Bitcoin Core nodes, multiple Taproot Asset nodes, and like without writing a bunch of your own Docker files, set something like that up. And these nodes are normally called edge nodes. So that's the one doing this price oracle. There's some public ones as well, but it's mostly on testnet. And in terms of other tools you may want for a hackathon, there's, again, like gRPC related tooling. So there's, I think, an LNbits extension that's working on using like Taproot Assets, and the LNbits project generates like Python from gRPC files, I think. So they generate from LND, but also you can generate from Taproot Assets or something else. If you want to work in Rust, there's like tools, Tonic and Pros, that will let you do something similar, and I think they work fine. If you don't want to deal with gRPC, there's like a REST gateway or like REST support directly from the daemon. And you may want to be using other like basic Bitcoin tools. There's this CLI HAL that is pretty useful. I think it's made by one of the guys that works on Arc now, but yes. Steven Roos randomly has this CLI tool that's very useful for working with Bitcoin script or PSPTs. And I'm sure there's others in like different languages, but that one works pretty well. I'm basically done with content. There are 3 slides of links which are going to be useful if you're actually working on the hackathon, of just like things that I cited here, other lists of resources, the first party docs, so like their actual docs and API pages. Again, really good. I'll be here, not working on this directly for a hackathon project, but if you have questions, that bash repo that I mentioned, there's like YouTube video series, and metadata format for images, which I think is supported by some indexers or explorers, so that should work out. And yeah, they have a Slack. There's also this Telegram channel for people running these edge nodes for like Lightning stablecoin transactions. But I couldn't figure out how to share it, so you can just ping me and I'll add you. That's basically it. So, thanks for listening. Anyways.
Hey, I had a question. Like you talked about like porting ordinals and inscriptions, and you also had the CryptoPunks example, and then you also showed the nice Explorer. When you like port or do anything, where does the actual like data live? Like where does the Explorer pull the images from? Just for my understanding.
So this is where it would have been useful to like actually decode a proof. There's actually, let me see. Okay, so this is a like data directory for.
You increase the size.
Too small.
Just like Command plus.
Okay.
Thanks.
This data directory for like a Taproot Assets daemon, and every time that daemon mints or transfers assets, it's going to generate like a proof, which is basically an SPV proof that something's included in the chain, and then a bunch of Merkle proofs that this asset is included in an output. Basically, that's it. And some other stuff, like validating that the script is valid and whatever. So it's going to put that in an SQLite database. There's Postgres support, but also it's going to generate this file that you can then decode with another Taproot Assets daemon, and the file is just the proof. But in the asset, there's also this metadata field. It's up to 1 megabyte, so you could put an image in there.
Okay, and then what does it point to? Like, is it like, I understand there's these universe servers. Like, is it served by the universe, or is it like, is it just a HTTPS endpoint?
Yeah, I didn't finish answering your question. The image data would be directly in there, so you could like hex encode it or like compress it or something and put it in that metadata field, and it'll move around with the asset. So every person that ever received the asset would also have this like image data. In terms of the universe, though, what would end up happening by default is when you mint an asset, you're going to also upload, this is like Genesis proof, right? So it's some Bitcoin transaction where there are no assets on the input, but there's assets on the output. You would upload that to a universe server. So there's sort of like, I guess, caching or archiving these proof files. And then you could go to like the web interface and see like, oh, hey, this asset was minted in this output, and like we can just do it actually.
So that's the proof file. So that's some sort of hash of the actual data.
No, it's all the data.
It's all the data. So
yes.
like if it's my CryptoPunk, I'll see the CryptoPunk as part of the proof.
So yeah, this is part of kind of one thing that I think it's useful is because you're not putting it on chain, there's like less size restrictions, or like you can just put a bunch of data in there. There's like a limit in the daemon just because that's useful, but you can just put all the data in there. It's not on chain. You like have to take care of it. There's no guarantee that anybody else is going to store it for you, but the benefit is that like some things become a lot simpler. So like if you were linking to something on IPFS and it goes down, it's like not a problem.
Okay, so you can also link to something on IPFS. Like
sure.
It's agnostic to where it is.
It's just a data field, and you can put whatever you want in there.
Okay, and then it's up to the Explorer to like fetch that through whatever mechanism.
Yeah, well,
like, there's no standardized way. Like it's not expecting an HTTPS endpoint. It could also be a raw hex.
Yes.
And like with the I don't know, with the data.
So I mean, there are web standards about like tagging images with like metadata. I think of like, are they PNG or JPEG or stuff like that?
Yeah.
So some of the explorers follow that, some of them don't. But that's like something you decide to do on your own.
Okay, so that's not standardized in Taproot Assets, kind of.
Yes.
Okay.
I mean, it's literally just a field for binary data, and you can do whatever.
Okay. Thanks. Yeah.
So yeah, we could look at like, hey, this is some genesis point. Somebody made a bunch of these, and this is its point on chain. This is like the anchor point is like the TX, I think, that it was created in, and yeah, it's in that block. And like this explorer is just parsing the proof data directly that someone uploaded to it. So you could mint stuff and never upload it, and like.
If I just find it as a standard, like
Sure. Sure. Like you could have some daemon that is doing both, right? So you could point at both. I mean, you could do whatever you want. But this is kind of the default behavior.
So if I have a Taproot asset and I want to send it to you, the thing that's on chain is just effectively like the Merkle root of my big sum subset tree, and then this proof data is like a Merkle proof that the asset amount and ID are like committed to in this Merkle tree.
Yep.
Is there a standardized mechanism for me to send all that proof data to you? Like, do I, does it like, I upload it to a Universe server and then you download it from that?
Yes.
Is it like peer-to-peer? Is it like encoded in a, Bolt 11 invoice? Like, what's the way that you get this data?
Yeah. So there is a there's in the repo. This is called like a proof courier.
Okay.
So the default. Let me see if I can find it.
Do universes generally like provide that as a
Yes.
service? Okay, got it.
So the default in all of these things
Sure.
is like Lightning Labs is running a universe that happens to also be a proof courier.
Yep.
So your client will by default like generate the transfer locally, verify it, push it to a universe, and then I think the receiver makes an address which specifies which couriers they will look at
I see.
for receiving a proof.
And then when I send it, I upload it to one of the couriers
Yep.
that they're going to use, and then they check it, and they only give me the
So
sandwich
they're-
or whatever if the proof data is there.
Yeah, they're pulling in the background and be like, oh, hey, I expected this asset on chain or something, and like, here it is. Let me get the proof. Let me verify it, and then we're done. But yeah, you could replace that. You could turn it off. You can run your own. You could do the pigeon thing. Like, you can change this.
I don't want to have to like deal with that. So like if there's a
That's
standardized
exactly why there's a
mechanism,
default.
that's, great.
So, yeah, that's that would be the default behavior.
I guess I have a question about PSPT offers with Taproot Assets. So I don't understand how it works exactly, but I understand that you can do the equivalent of creating a limit sell order with Taproot Assets.
If it's whatever diagram Route 13 had up before, it's the same thing.
Yeah.
Yeah.
My question is if you can create essentially a buy order for a UTXO that then someone else can fill. If that makes any sense. Like, for example, let's say that you had a UTXO with a Taproot asset in it,
Mm-hmm.
and I wanted to make an offer to you, not knowing you, to buy half of your Taproot assets.
Sure.
Would I be able to, because that would require me then to generate a proof on your behalf without knowing your keys. I was wondering, is that something you can do?
I may have an answer, but there's this, like there's PSBTs on L1, right? On Chain Bitcoin. There's also PSBTs in terms of assets. So what you could do is like make a PSBT where the input is my asset and the output's like your asset plus some change, and you could send this to me and be like, hey, would you accept this? This PSBT that represents what I want to do in terms of an asset transfer. But the thing that I don't think exists is like tying that to what happens on chain in terms of like this is the price I would pay for this asset. So like I think it's basically the same constraints that Route 13 had up earlier of like we can do things in one way but not the other. But there is tooling to make it easier to communicate about what transfer you want to do, like with PSBTs. But
So just make sure I understand. So with Rune, you can't create a blanket limit buy order that anybody can fill. But you can go one by one to a UTXO. I want to buy that one, and I only want to buy this amount of that one at this price. And what you're saying is that with Taproot Assets, you would have to commit in the proof of your own output their change, but that would then mean that they can't actually access that themselves because it's in your UTXO. Like you would have control
Yes.
over the UTXO.
Almost. You'd need a L1 transaction with multiple outputs. So one of these outputs would be controlled by them, but they could easily post enough information for you to know which pub keys to use. Yeah, so you could construct a change output for them.
Okay. But
But-
they would have to post additional information. other
Yeah,
than the
there's going to be
UTXOs.
some interactivity,
Okay.
and it's like
I got it. Okay.
you could maybe more easily make a marketplace for this kind of stuff, but it's basically the same constraints as there are with drones, I think. Just maybe a little easier to do it on a message board. But
Could you inscribe all of the proofs and make Bitcoin be the universe?
I get the proofs are pretty small. I don't know. Please, if you do it, then don't tell me. But I mean, the proof is less than a megabyte here, and I think this is multiple transfers, so you could. I think the default proof is pretty small because it's just some Merkle proofs, and the asset metadata, which is up to a megabyte. So like, yes, but I don't do what you want. But, yeah. Cool. I'll be around for other questions or whatever. Good luck.